Quadrilaterals are a special kind of polygon. It's a polygon that has four sides. And this particular shape shows up often enough in practical situations that we can break this down into several different special types of quadrilaterals. For example, you see these in tabletops, and rooms are often rectangular. You'll sometimes see rectangles, trapezoids, occasionally triangles in the shapes of lots of land, depending on exactly how the boundaries work out. But the boundaries are usually straight lines. Um, so again, these shapes will often come up there as well. So I've got four of the most common types here. A parallelogram is a quadrilateral with two pairs of parallel sides. A rectangle is a quadrilateral with four right angles. A square is a rectangle with four congruent sides, and a trapezoid is a quadrilateral with exactly one pair of parallel sides. So I've got some examples here for us to look at. And you're welcome to pause the presentation if you like, see if you can't match the definitions to the shapes on your own, and start it back up and we'll go over it together. So for a parallelogram, and as I do this, let's just assume that sides that appear to be parallel are, and angles that appear to be right angles are right angles. So with that said, this one on the upper right looks like it has two pairs of parallel sides. So that's going to be our parallelogram. This one down here at the bottom has four right angles. So this one is going to be a rectangle. And now this one up here in the upper left, this one also appears to have four right angles. So this one is also a rectangle. However, since it also appears to have four congruent sides, I'm also going to say that it's a square. So there is some overlap with these definitions. Sometimes something can fit into more than one category. Right, now finally, a trapezoid has exactly one pair of parallel sides. So if you look up at that parallelogram, it does, you could look at it and say, well, it does have one pair of parallel sides, right, the top and the bottom. But this word exactly here is really important. Right? The parallelogram is not also a trapezoid because it does not have exactly one pair. The trapezoid is just going to be this one here. So one measurement that we talk about when we're talking about polygons in general, I'm talking about it in the context of a quadrilateral here, but this really applies to all polygons. The perimeter of a polygon is just the distance around the object. It's the sum of all the lengths of its sides. Now, in general, there's not a whole lot we can say about the perimeter of a general n-sided polygon beyond it's the sum of all of its sides. We can be a little more specific when we're talking about rectangles and squares, which is what I've got here for us to look at. With a rectangle, these top two sides, the two horizontal sides, both have the same length. And the two vertical sides also both have the same length. So the perimeter of a rectangle is W plus W plus L, which is 2W plus 2L. So yeah, we actually can kind of come up with a formula for the perimeter of a rectangle, and occasionally that is going to be useful. Now over here with a square, we can take this even further. With a square, all four sides are the same. So in this case, L and W are both going to be this common length S. So if I put that into my rectangle formula, this becomes 2S plus 2S, which is 4S. Again, every once in a while, having that specific formula is going to be a little useful to us, but in practice, most of the time, yeah, you can also fall back on this basic add up all the sides, and you'll get the right result. So if you remember, back when we were talking about measurement, we spent quite a bit of time talking about area. And we did it in kind of a general sense. We just said the area is how much space is covered by a figure. And anytime we want to talk about a specific figure, I just gave you the area, and we did stuff with it. Well, in the next lecture, we're going to revisit this subject of area, and we're going to look at some formulas that you can use to calculate the areas for some specific kinds of shapes.